All right, today we're jumping into a different kind of detective story. This one doesn't happen on a dark street, but deep inside the circuits of a really complex machine. Our case, we're going to solve the mystery of the EX0379 alarm. So, every good investigation kicks off with a clue, right? For us, it's this, the XE0379 alarm. And this isn't just some boring warning light. It's the machine literally signaling that there's a major contradiction inside itself, one that it can't figure out on its own. It's a cry for help. And that leads to the big question, doesn't it? How in the world do you solve a mystery when your only witness is the machine? Well, to crack this case, we've got to open the file, follow the evidence, and learn to speak its language. So let's dive in. Okay, so first things first, we're dealing with a machine that's basically contradicting itself. And before we can even think about fixing it, we have to understand what it's even trying to tell us. Think of this as our case file. The alarm's official name is a turret index direction error. And really, it's as simple as it sounds. The machine's brain, the PLC, told the turret to spin one way, but it went the complete opposite way. It's a classic case of the machine just not following orders. And that brings us right to the heart of the problem, command versus feedback. This isn't just some random glitch, you know? It's a serious breakdown in the machine's internal communication. Yeah, the technical term for this is a command versus feedback mismatch. And here's a great way to think about it. Imagine a general shouts, "March north," but the scout on the ground radios back, "Sir, we're marching south." The system is smart enough to go, "Wait a minute, those two things can't both be true." And bam, it triggers the alarm. So you've got two sides to this story. On one side, you have the command signal. That's the PLC, the brain, giving a direct order. Then you've got the feedback system. Think of these as the eyes and ears on the ground, the sensors that report what's really going on. The X0379 alarm goes off when these two stories just don't line up at all. And here it is. This is the smoking gun. The command says loud and clear, CMD TCW or go clockwise. But the report from the field, it says actual TCCW, counterclockwise. Total opposites. So now we're the detectives. And the big question is, who's wrong here? Was it a bad order or was it a bad report? That's what we're about to find out. All right, like any good detective, you start at the beginning of the trail. So step one, we're going to follow the order. We have to check if the command sent from the PLC was even correct in the first place. Was it clear? Was it sent properly? So, our investigation begins right at the source, the PLC outputs. We've got to make sure that initial command was sent out right. I mean, it's the most logical place to start, right? Before you start tearing apart the machine, you got to rule out a simple glitch in the message itself. And here's how you do it. First, you check if the correct output is even getting power. Then, you look at the physical parts. You know, the solenoids, the relays. Think of them as the muscles that carry out the order. Are they working? If all that looks good, well, we can be pretty sure the command itself wasn't the problem. Okay, so if the order was sent out perfectly, our investigation takes a turn. Now it's time to question our witness, the feedback system. We got to look at the report coming back from those sensors. This means we're zooming in on the proximity switches, the A and B phase sensors. See, these two have to work together perfectly to track how the turret is spinning. If even one of them is off or they're not synced up, the whole report they send back to the brain is going to be totally wrong. So the next step is a hands-on inspection. You check the A phase sensor, you check the B phase sensor. Is it dirty? Is it just knocked out of alignment a little bit? Could it be a bad wire? You know, it's funny, a lot of the time, the solution to this whole big mystery is just a tiny little adjustment or a single faulty sensor. And here's a super helpful tip from the case file. It's a real insider clue. If you happen to see another alarm pop up, an EX0378, that is a massive hint that your problem is almost certainly with those A/B phase sensors. It helps you zero in on the culprit way faster. So, let's say we found the problem. Maybe it was a bad solenoid in the command or a wonky sensor in the feedback system. We fixed it. We're not done yet, though. There's one final step to officially close this case. And that last step is the system reset. Now listen, this is super important. Hitting reset is not the fix. It's not a magic button. If you just push reset without actually solving the physical problem, that alarm is just going to pop right back up. Think of the reset as the paperwork you file after you've solved the crime. Yeah, what you're really doing is clearing the alarm from the machine's memory. You found the issue, you fixed it, and now you're telling the PLC, hey, it's all good. You can trust your sensors again. Case closed. And that's what lets the machine get back to work. So, let's just recap our whole detective process, shall we? We started by actually listening to what the alarm was telling us. We figured out the core conflict, that command versus feedback problem. Then we followed a logical, step-by-step process. First, check the order, then check the report. And only when the real physical problem was fixed did we hit reset. It's just a beautiful example of how good systematic troubleshooting works. And that kind of leaves us with a bigger question, doesn't it? We just figured out how to solve a contradiction inside a machine. But what do you do when the bigger, more complex systems we rely on every single day start to contradict themselves? Well, as we just saw, the answer usually isn't a quick fix. It's about having a clear, logical process to find out what's really going on. Thanks for joining me on this case.